Hi, everyone. Thank you for showing up for this webinar. And today I want to talk about something that is very much near and dear to my heart. The issue of supporting stuff in production. Now, this is interesting because there is this old adage about what is debugging. And debugging is the process of being a detective where you are both the victim and the murderer. And if you think about it, this is a really, really interesting statement, and also something that is quite painful. And the problem with this is that this is when it happens on your machine, because you're a detective, you can detect stuff, you have tools. What happens when something like that happens in production? Well, this is fun because it's just like debugging, except that you cannot debug. And sometimes there are logs, and sometimes you have tools available for you. And sometimes you even know what the problem is, as is, you know, there is an error, there is something. And there's typically someone who is shouting at you, and this is more or less how I usually feel when I have to debug on that. When I have to solve a production problem, because the amount of available information and available facilities to actually solve the problem is almost minuscule compared to what I usually have. And there is also another critical problem. I'm typically not talking to someone who knows what's going on. Sometimes I'm talking to the literal janitor, you know, that person who walked by while the server was on fire and they called you. And they have no idea what the system is, who set it up, anything whatsoever. But you still have to be able to operate and give them some insight about what's going on. And one of the things that came out of having to deal with those support issues is that the entire architecture of RavenDB have changed in order to make most of the support calls a lot easier to deal with. So let's talk about some real-world support cases and discuss what actually happened. So we have a user who is doing something relatively simple. They're deploying something to production, and it fails. Well, sometimes production deployment fail. And then they do the reasonable thing and they say, hey, let me undo the change. Let me roll back my changes. And it also fails. The application doesn't start up. Now, they're running multiple servers. They only deployed to one of those servers. All of the other instances running the old version of the code, which they've now redeployed, are working. Except the new one doesn't work. And they have no idea what's going on. So they call us. And they call us, and the reason that the application fails is that there is some problem with the database. So they call us. And this is a really funny state, because on one hand, you have a system that is perfectly operational. And on the other side, you have a system that is completely broken. And the first thing that we started to do was, okay, let's see what the error is. And the error is quite simple. The server certificate expired. Well, that's cool. That explains why there is an error. But while all of the other systems are working, I mean, I'm looking at, I was looking at the RavenDB Studio in the browser. No warning whatsoever. And then we looked at the dates. And it turns out that the server in question was running in UTC. And the time zone of the question was -8 or something like that. And what was the problem? While they were working, in the middle of the day, as far as they are concerned, the server, the server, they changed. So now the server certificate was failing. From the perspective of the browser, well, it was still yesterday, so that was fine. From the perspective of, but okay, so that explains why the new deployment failed. What about the old deployment? They're now working. I mean, the system is partly up, but why? It turns out that the existing instances are running on already established connections. So because those connections were already established, they kept on working, but it wouldn't be able to open any new ones. Well, okay, but no big deal. RavenDB has facilities to update a server certificate. In fact, most of the time, it happened automatically and transparently. You aren't aware that this happened. Why didn't it happen this time? The customer has their own certificate authority. And that's fun. Why is this fun? Who can generate a new certificate? Well, it turns out for this particular organization, that was the domain administrator who can use Active Directory to generate a certificate of those trusted by their internal systems. As you can imagine, the domain administrator who was not on the call wasn't available. So we're now looking at a situation where the system is now in effectively sudden death mode because it's partly working and partly not. So that's fun. And at least in this case, this is really straightforward to figure it out because we understand how the system is working. It's also super critically important that we understand the sort of errors that we have. And I can tell you that I think that at least half the success of a good developer or good IT person in general, read the error, not say there was an error, read what it actually says. Now, let's talk about another fun scenario. By the way, in this case, what happened was that they actually called and got the domain administrator to show up at the office and fix this. So not that big a deal. But the aspect that the system is partly up because it haven't had a chance to fail yet was a really interesting mode to be in because, oh, you cannot restart the server. If you restart the server, the entire system would be down and things like that. Here's another example. So we have a customer and they had this really interesting folder structure on the disk. They have a test database, and for whatever reason, they have a critical database nested under this. And now, as people do, they deleted the test database. And that also deleted the critical database. So here is an interesting factor. What happens now? Well, we're running on Linux, so you're allowed to delete open files. Okay, that's fine. And they will be removed when the last entity is closed. So what happens now is that we are now running in an environment where the following things will happen. Whenever RavenDB needs to create a new file in that directory, it would fail because the directory does not exist. Except that maybe it does. I tried to imagine that this is 1 a.m. We're trying to resolve this, and I have zero idea whatever RavenDB would, when it attempts to create a file, would create also the directory structure. Let's say that it does, and if so, then the system would continue to operate normally. But if it doesn't, then the moment that we create a new file, we fail. RavenDB sees that there is a critical failure right into disk and going to shut down and try to do things gracefully, which would actually close all of the handles and delete the data, which is something that we would like to avoid. So here is a trick that you can use in something like this. You can run this So this is a run list in bash for the virtual proc file system. And now you're saying, hey, show me all of the file descriptor for this process, which is the RavenDB process. And you would see something like this. And you're then able to create a link from the open file from /proc/71/fd/3 to the original file and restore it. I'm using quotes in this case because you're not actually restoring this. You're actually relinking it back and it hasn't been deleted yet. Now, if we close the file, then we need to actually do restoring of the file from deletion, which is a huge big mess, and we would like to avoid that. So those are two small production support cases to look at. Now let's look at some of the big ones. One where we really had to work for it. We have a case where a server went dark. It stopped responding to the network. And this is one of those cases where it really, really sucks, because if this is the only information that I have zero idea what's going on. Let me list you some of the options for failure in this scenario. First of all, the always classical, there is a network problem. There is a firewall problem, which is distinct from a network problem. There is the process died, except that in this case, a dead process would give you a different error. It would give you no one is listening to this port versus no response. It is possible that the server is dead, etc., etc. Or always fine, there is something wrong with the server or the service. For example, maybe it's busy paging. This is a classic example for not responding to the network. If we reboot the system, it fixes itself. But that's not a solution. So this actually happened on a RavenDB cloud instance. So this is something that we manage and own. And this is really strange because we have the facilities to detect and resolve those issues automatically. If there is something like that, the cloud infrastructure is expected, our cloud infrastructure is expected to detect, resolve that, and manage that, but it didn't. The first that we heard about that was that the customer called us. And this is weird, because the first thing that he did, it went to the portal, restarted the machine, it worked, and then they complained about this. And this is something that you do, because if there is a production problem, then the first thing that you would do is fix it. And then you investigate what happened. Which means that if we want to avoid errors, we have to figure out a way to manage that. And this is not a new feature. This is not a new request. So what you can see here is that we have quite a lot of tools to go into an existing live system and try to figure out what's going on. Of particular importance is this thing, the debug package. And the debug package is going to give me a lot of information about the currently running server. The idea here is that I have a bug in the system, something, I'm going to restart it. But I'm going to ask, give me just a little bit information, gather everything very quickly, so I can now do offline analysis about what the system was doing that caused the problem. Now, as you can see, this may take up to 30 seconds or a minute, and the output of that is going to be a zip file that contains all of this information. And here is the zip file in question. And we have information for every one of the database on the system, and a whole lot more details in addition to that. For example, let's look at this one. And what you're able to see here, JSON, change. Okay, it doesn't want to do that for some reason. What you can see here is that we have some information about ping time between the various nodes. Let's see if now it will work. No, it doesn't want that. Okay, and there's a whole bunch of details here that you don't actually care about for right now, but it's really, really helpful for us to figure out what's going on. So we have the tools for do that, but we need to be able to detect that. So now the question here, how can we miss it? The customer says, hey, my entire system was down. This particular node wasn't even responding. So we're looking into that. And it says our monitoring system pings the server on a continual basis. It says it's okay. What can this be? Well, something very obvious. Firewall issues. A typical scenario here may be that the customer changed the firewall configuration and did not include the server or something like that. Or there was a delay in updating the firewall rules or something like that. But the reboot fixed that, so doesn't match. But that's the information that we have. And now it happened again. Exact same scenario. Monitoring says this is up. We have proof. Customer said this is down. And it was already rebooted by the customer because they wanted the system to work. What do you do then? Well, it turns out that what you do is you implement additional monitoring to be able to detect that. And we implemented that, we pushed it to production, and suddenly we had an alert. We have one monitoring system that says, yay, the system is up. Another says that no, that we cannot access the system. Which those are both running on the same server. So there is no networking issue. But here's where it's got to be really, really, really strange. I'm unable to process HTTPS calls, but I'm able to process SNMP, Simple Network Monitoring Protocol. So it is a firewall rule? What's going on? So the first thing that, in this case, the first thing that you log into the machine to try to figure out what's going on. And now we are starting to see something even more interesting. Because from the local machine, you can see that the behavior persists. I'm unable to run any HTTP calls to the server, but it would absolutely respond to SNMP calls. That makes no sense. I mean, I can see that it's listening. Netstat says that it's listening to those. There is no local firewall to block me. Now, maybe it's a problem with TLS because this is what we're using. And we run into scenarios where TLS is broken in some fundamental way. For example, maybe we need to contact some other server to download the certificate chain or something like that. And that other server is not responding. So that may behave that I'm able to connect, but unable to complete the TLS handshake, which behave exactly like this. So we have a backdoor. It's not actually a backdoor because it's protected, etc. But in addition to listening over the network, RavenDB also listens over a Unix socket, which is only accessible on the local machine, and you have to be root to access that. So we try to connect to that to be able to see what's going on. But it does not respond. RavenDB does not respond on the Unix socket. How can that happen? Now, I'm looking at the log file And there are entries there that says, oh, I ran this and this backup, or this usual cleanup happen. So the process is running. In fact, if I'm looking at the log file, it complains, I try to contact my peers, the other nodes in the cluster, and I was unable to do that. But from Bash, I'm able to ping the other nodes in the cluster. From Algorithm, there is no issue whatsoever in the system. So this is weird with a capital W, and we have no idea what's going on. So we decided to see what's going on. We know that a restart would solve that, but it doesn't work. So let's see what's happening. So RavenDB is running, and it is able to do decision work, but it can touch the network, not external, not internal, which is really interesting. But on the other hand, it is able to respond to SNMP requests, which is network, both local and remote. Now, RavenDB in the cloud runs in a triple configuration. So you have 3 nodes running in separate availability zones, which means that we could afford to inspect a node and not immediately fix that. So we thought that this may be some problem with Kestrel, the web engine that we're using. But that would explain the issue with the Unix socket. It didn't match. And if there is a network problem, why does SNMP works? So we decided to look using STRACES to see what is actually happening on the system. Maybe we'll figure out some system call that we are blocked. So we're looking at that, and we're running STRACES, and there's a lot of networking calls, which makes 0 sense, because the system is not working. And I have no idea what just happened. I ran STRACE, and it suddenly worked. Okay, I missed my chance. Now I have to wait for this to happen again. And that's when we realize that this is a Heisenberg. If we try to observe this, it will be fixed. If you use STRACE to look at what the server is doing, it automatically fixes the issue. If you attach a debugger, automatically fix the issue. If you try to take a core dump, it fixes the issue. Attempting to figure out what's going on fix the issue, so we cannot figure out what's going on. That's really annoying and quite hard. So now we have to start figuring out what exactly is going on. We have to try to figure out how this is happening. And we do that by old school, basically. Let's go and start reading code. Now, I highly recommend, by the way, to go and look at the .NET sockets code. It's really clean, it's really nice, and it's really easy to understand what's going on. It also uses a lot of async operations. Okay, so if you have async operations, maybe it's the thread pool. There is a concept of a convol. If the amount of work that you have to do in the thread pool is bigger than the number of threads that you have, and all of them are blocked, everything is waiting. So we may be able to access the data on the network, but not have a thread available to process that. But SNMP works. And this is the relevant code for handling SNMP message. And as you can see, we are doing a synchronous reads from the network. And then we are actually handling that in an async fashion. So that makes no sense. And we still don't know what's going on. So we have to dig deeper. And the way that .NET works is that it uses something called EPOL. And EPOL is how you do async IO in Linux. It is very well known, well-known practice. Everyone who wants to build a high-end network system uses that. And actually today you would probably use IO-URIN, but that's for later. So .NET uses something called edge trigger events, epool AT, well, as I like to call it, epoulette or electric chicken. And all of the async work goes to the same location. So all of the sockets in .NET go to one thread. And this one thread would call to this for any async socket operation. And this is what this looks like. You wait for the sockets on any, or some event from the socket from any number of sockets. And SNMP version uses the synchronous API. It doesn't use epoll. So that is a really important hint. Now look at what we have here. We are checking that epoll wait, and this may end up with an error. If this is less than 0, this is an error. But we'll retry if this system was in this syscall was interrupted. And that's important because this is what we see in the man page. Subsystem call return with enter if we call PTRACE. So when you open PTRACE, it would interrupt subsystem calls, including epoll wait, which exact behavior that we are seeing here. When we attach to a process in Linux, this system call would be interrupted and then immediately retried, and then it frees the frozen system. So this explains everything except why we are hanging. And if you think about this, what we end up with is it's a kernel bug. In fact, it is a kernel bug. Some race condition inside of the Linux kernel. And that was a few weeks of our life that we wouldn't miss because it's the kind of mystery that you keep digging and digging and you have no idea what's going on. Let's talk about another example. And this is another example of some network issue. By the way, I'm giving those examples because those tends to be fairly nasty problems. And at the same time, those tends to be the most common ones. So there is usually something in the network, some problem. Now, in this case, we started to notice that we deployed a new version of RavenDB to production, and the rate of replication errors went up. Now, RavenDB is robust. We expect to have network issues. So we handled that. But the high rate was concerning, so we had to figure out what's going on. But it was really hard to figure out what exactly is happening. And then we found a repo. We have a data set that would not replicate between two nodes. So, and the way that we figure it out is that we have a lagged replication. So these two nodes did not replicate to one another. And this is weird because this was for one database. Another database on the same two nodes replicated perfectly fine. For this particular database, for this particular two nodes, would fail with a timeout. It would replicate to two other nodes with no problem, but not this one. And that was super, super weird. So it's not a network because it's working. It's not the data because it's also working. But the network plus the data on this particular scenario was what? So we started trying to narrow things down. We have a data set. What other items can we remove? So this is what we started. We figure out that this only happened between source Windows to a destination Linux. It only happens over HTTPS, which means that if we take the same two servers, run them over HTTP, it doesn't work. Run them over it does work. Run over HTTPS, it does not work. And there was a new feature that touched TCP connections called ZSTD compression. And the idea here was that RavenDB would compress the data over the wire to reduce the amount of bandwidth that you're paying for. And apparently there was a problem there. So now that we figure out what was the issue, let's see what happens. What you see here is a really, really trivial compression. So basically, if you have a run of the same value, it will skip it. And that's about it. So I'm writing data, and I would keep on writing data until I'm done. Now, hopefully, the length of compress is going to be smaller than the length of the buffer that I'm feeding this. And this is the typical usage. So write the data, compress, and output it out. Notice that there are some cases where the length of the compress is greater than the length of the buffer. Not touching that, but just keep it in mind, this is generally useful. What is really relevant from our perspective is that length of compress can be 0. And how can it be 0? What happens if I have these two writes, which output the same value? I'm not actually going to output the value out. I have no value to output. I just need to increment, oh, this value repeats more times. Okay, that's good. So let's see what happens then. That means that this compress is 0 bytes, and I'm writing 0 bytes to the stream. Well, this is a network stream. So what happens when we write an empty stream to the network? This is the structure of a TCP packet. And what you can see here, this is actually an IP packet, to be fair. What you can see here is that the total length of the data, and this can be 0. Now, what's the meaning of an empty packet at the network level? Well, it means that don't send in data, but keep the connection open. Because otherwise there might be a timeout and the TCP keep alive feature around that, etc. So this uses TCP and it's working. And we know that if we are running the same code over HTTP, it is okay. HTTPS is the problem. So what happened when you're using TLS? What does it mean to send empty data? Well, you're not actually sending empty data because there is the TLS envelope, but you can send what is effectively, this is the size of the envelope, so the output of this would be 0 bytes. Now, the reason to do that is to mitigate something called the beast attack, which is very old if you're using a modern cryptographic protocol, such as XChacha or GCM or something like that, you're okay. But deep in the guts of OpenSSL, you have this. If you got an empty record, and it's more than max empty records, fail. And empty records is defined as 32. With apparently this is some reasoning behind that. So to summarize the situation, we have a scenario where if we compress data over TLS that has a lot of consecutive repetitions, so we're sending the data out over sending empty packets out, basically. And we're sending over 32 of them, OpenSSL would think that we are trying to attack it and abort the connection. And it's happened only on Linux because on Linux we're using OpenSSL. For some reason, it only happened from Windows. We haven't bothered investigating exactly why. But once you had this triad of features, you have a problem. And you had to align everything just right on several different layers of the system in order for you to actually get the problem. And this is really common when we talk about the nastiest problems. If you come to me and say, hey, I have a high memory usage in my system, then it's actually pretty easy for me to tell you, oh, let's see what's taking, let's see what the reason for that is. So I could go to a live server and 1 second. There we go. admin/debug/stats. So what you can see me do now is here the memory statistics. In fact, in some cases, I can drop all the way down to tell you the specific ID of the network, of the thread, and how much it allocated. In this case, I don't really have a lot of allocations. But I can go ahead and start some work. And let me go ahead and let's reset an index. And hopefully now you can see some more work going on. I can also go here and start looking. Oh, I can see that this one is using a lot of CPU. Let's see why. And it will give me those results. So those are the simplest. So, okay, this is actually generating the stack trace. Let's see this one. This is the heartbeat worker to connection, and it would give me some results out. So I have the ability to look at details. And if I have a high CPU utilization here, I can figure out what's going on. I can figure out what the memory is. Those are the easy things. Things where the system stop operating normally are a lot more complex. So for example, what happens if I have disconnect between nodes or partial failure? The example I gave in the beginning where some of the connection would fail because of the server certificate expired, but some of them are already existing. This is a really nasty problem because my heartbeat may say I'm okay, but my actual system is down. And the problem here is that my heartbeat may be actually reusing a TCP connection that created a while ago. So you have to really understand all the way up and down the stack in order to be able to figure out what's going on. And with that, I would love to take any questions that you have. In the meantime, I want to point out something really interesting here. I don't know if you notice, but the live test instance is now using RavenDB 6.0. We have nightlies and beta out, and I would dearly love it if you give it a shot, test out what's going on. There is a lot more going on inside the hood that we would love to have your insight on. And for fun, notice that in this case, I'm running on one node, but notice that we have sharding here. So you can give it a wheel and tell us how you like it. And I don't think there are any questions. If you have any, feel free to send us an email to oren@ravendb.net. And thank you. Have a good day. Bye-bye.